We have this tire, and we want to paint the upper side of it. To do that, we need to find out the area of this shaded region. But here's the catch. Someone took a steel rod, exactly 50 centimeters long, and found that it fits perfectly across the tire like this, touching the inner circle at one point, just like a tangent. Now, here's the challenge. Using only this piece of information, can you solve the problem? At first glance, it feels like mission impossible, right? I mean, how can we figure out the shaded area with just that? But trust me, there's a way, and the solution is both clever and satisfying. Before we start, let us convert this tire and this rod into geometrical shapes like circle and line. Now, label the radius of the inner circle as A, and that of the outer circle as B. So, the area of this donut, or the shaded region, will be the area of the outer circle, or pi times b square, minus the area of the inner circle, or pi times a square. Take pi as common, and this will become pi times b square minus a square. Great. Now, what can be the next step? We have this line as a tangent to the inner circle, and it also acts as a chord for the outer circle. You might wonder, what is a tangent? A tangent is a line that just touches the edge of a circle at exactly one point. It doesn't cut through the circle, it just grazes it. The key thing to note is that the line from the center of the circle to this point of contact is always a right angle to the tangent, which means the radius of this inner circle makes a 90-degree angle with the tangent. Interesting, isn't it? Not only that, now consider this outer circle. This same line is a chord to the outer circle, and here comes the magic. In a circle, if you draw a line that is perpendicular to the chord from the center of the circle like this, then that line divides the chord into two equal parts, and it is also called a perpendicular bisector. So, the radius of this inner circle will divide this line into two equal parts. Thus, this length will be 25 centimeters. Now just complete this triangle such that it will be a right-angled triangle. We can use our favorite right-angled triangle theorem to get b square equals a square plus 25 square. Now take a on the right side to get b square minus a square equals 625. Wow, amazing! You can see that we don't need any other information here because the shaded area is simply pi times b square minus a square, which becomes 625 pi. Don't forget to put the centimeter square. And there you have it. With some clever geometry, we've figured out how to solve this seemingly impossible problem. So good.